Circles and coordinate geometry. So you're given the centre of the circle, so you can immediately write down the left-hand side of the circle equation. X minus a all squared plus y plus a all squared equals, and then we need to know the radius of the circle. That's easily enough found. Draw the radius on from the origin to the centre. Just note then you've got a right angled triangle here, which should help you work out the radius. If it's just Pythagoras will give you that that's got to be the square root of 2 times a. If you square that radius to get the r squared that needs to sit up here, well, you get root 2 squared gives you 2, and a squared gives you a squared, so 2a squared sits there. And there's the equation of the circle. Part B, you're given that 1 minus 5 lies on the circle, and then we're asked to do something with that. Well, let's just substitute that in and see if we can figure out something. It turns out that we can work out what the value of a is. So x is 1, y is minus 5, expand, and then simplify. The a squares on both sides of the equation cancel. That shrinks down to minus 12a equals minus 26, and therefore a is 13 over 6. So pi r squared will give us the area. Pi is pi. R squared is just this thing here, remember? We don't need to try and calculate r again and then square it. Look, there's r squared, it's sitting there. So pi times that for our value of a. So pi times 2a squared, which is pi times 2 lots of 13/6 squared, which gives us that answer, as you can see.